In this lesson, we're going to examine theoretical probability. Theoretical probability is what should happen in an experiment as opposed to experimental probability is what did happen in the experiment. So in absence of actually doing the experiment itself, we can predict what should happen. To do this, we're going to figure out the probability of some event. The way that's going to work is how many different ways can that event happen out of what are all the possibilities of things happening. And then for notation, our probability is still the same, probability of an event, and the number of ways that thing happens out of our universal set, all the different things that can happen. So for instance, if I were to roll a dice, what are the probability of rolling a 2, the probability of rolling my event, 2, there's one way to get a 2 out of the 6 different possible outcomes that could happen. Okay, we're going to try some. This just takes a little bit of practice to get the hang of this. We'll do some basic ones today, then we'll move into more complicated events down the road. So, a card is pulled from a deck. Now, we are going to use decks of cards a lot in this course, so we kind of need to be familiar with them. In this case, we want to know what the probability of an ace is. In any deck, there are 52 cards. So our total for cards is always going to be out of 52. And just a reminder that we have the numbers 2 through 10. And we have an ace at the beginning, and we have a jack, a queen, and a king at the end. There's 4 different suits: clubs, spades, hearts, and diamonds. So 4 of each of these 13 things gives us our 52 cards. Of those, 4 of them are aces, so the probability of an ace is 4 to 52. And I'm totally fine if you leave it as 4 to 52. If you want to reduce it, you can say 1/13. If you want to turn to a decimal or percent, you can do that too. But it's totally fine to leave it as a fraction. Next one. Okay, what is the probability with 2 dice of rolling the following? Okay, part A, snake eyes. Snake eyes is having a 1 and a 1. Well, the only way we can do that is one way. Both dice have to have a 1 on them. So the question we already need to ask ourselves is how many different ways can I roll 2 dice? So if we stop and think about this for a second, we have 6 different ways of rolling the first dice, 1 through 6. And 6 different ways of rolling the next dice, so again 1 through 6. So there's 6 combinations on each dice. 6 times 6 makes 36. So there's 36 different things we could do. Okay, how about rolling a pair? Well, the probability of a pair, I'm going to use P for pair this time. How many different pairs are there? Well, they're both 1s or 2s or 3s or 4s or 5s or 6s. So there's 6 different pairs out of the 36 different ways of rolling a dice. Okay, how about a sum of 7? A sum of 7. That means my 2 dice, and a point here I want to point out to you guys. Always think of your dice as a different color if you can. So, for instance, I have a 1 on one dice and a 6 on the other dice. Well, that's a sum of 7. Or maybe a 2 and a 5. Or a 3 and a 4. Those are all sums of 7s. But this is different than 4 and 3. Or 5 and 2. Or 6 and 1. And they're different because I can tell them apart. A red 1 and a green 6, 2 different dice, is different than a red 6 and a green 1. They're different. I can tell them apart. So whenever you deal with dice, think of them as different colors. So how many different sums of 7 are there? Well, we have 6 different combinations of the 36. If you actually look back for a second, the probability of a pair is the same as rolling a sum of 7. Okay, then the last one here, the probability of rolling a sum of 11 or higher. So how do we get 11? Well, it could be a 5 and a 6, or a 6 and a 5. And no other combinations, dice only go up to 6. But it could be something higher than that. Well, higher than that could be a 6 and a 6. I can't flip a 6 and a 6. Just to point that out. Okay, a red 6 and a blue 6. And you say, well, let's write them the other way around. Well, isn't that a red 6 and a blue 6? They're the same. So this cannot be repeated, okay? So how many different things are a sum of 11 or higher? Well, there's 3 of them out of, the 36 different things. Again, if you want to reduce that 1/12, you can do that. Okay, so there's some basic introductory things what we can do with theoretical probability, the idea of what could happen as opposed to what did happen. So let's go back to some ideas we talked about in this course. Complementary events. We talked about this when we looked at sets and Venn diagrams. Well, the same things can happen with probability. The complement to an event is the opposite outcome. So if PA is what did happen, PA not, or not A, is what didn't happen. So for instance, the probability of rolling a 5 is 1/6. Well, the probability of not rolling a 5 would be 5/6. And this math is very easy to do, even when we get to really complicated questions, because since PA and PA not are the only two possibilities, they complement each other, they always add up to 1. So if I know the probability of the event, I can do 1 minus the probability it doesn't happen, or vice versa, I want the not, 1 minus P of A. I want to point out to you one thing here, 1/6 and 5/6. Okay? The two numbers on the top have to add up to the number on the bottom. So when I say you can do this math really quick, so for instance, I say the probability of an event, let's say we did some real big crazy calculation, it came out to 31 out of 243. Well, the probability that didn't happen, really fast, I know it's still at a 243, I can just take 243, subtract the 31, and what I'm left with has to be the top of the other number. Because together I know they make 243. Okay, so if you have an event, you want its complement, or vice versa, very quick to figure that out. I'm going to try some again. Using the digits 1 to 50, determine the probability of the following events. So I want things that are divisible by 5. Oh, there's 50 things all together. How many are divisible by 5? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. There's 10 of them. How about an even number? Well, we know there's half of those. How about not divisible by 10? Now, this is the case where I don't really want to go through and say, well, 1's not divisible, 2's not divisible, 3's not divisible. It's actually easier to find the ones that are divisible by 10. 10, 20, 30, 40, 50. There's 5 of the 50. So how many are not? Well, that's the complement idea. So 50 minus 5 makes 45 out of 50. Way faster to calculate that. Things that have a 3 in them. So 3, 13, 23. Here's the tricky one. 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, and 43 all have 3's in them. There's 14 of those. And, oops, anything that has a 3 in it. And the last one here is not a perfect square. Oh, I see that word not again. So it might be easier to figure out the ones that are perfect squares. Which ones are perfect squares? A perfect square is a number where you can square root it. You get a whole number. So root 1, root 4, root 9, root 16. Oops, should be a 4 there. Root 25. Root 36, and root 49. 1, 2, 3, 4, 5, 6, 7. There's 7 things that are perfect squares of the 50. So how many are not? Well, the complement, 50 minus 7 makes 43 out of 50. And again, I said it's pretty easy to figure out the complement if you know the initial event. Okay, there's another way we can express the likelihood or the level of confidence of something. We call these things odds. For people who like to watch sports, lots of games, they tell you the odds of different teams winning things. Well, this is where it's gonna come from. Like probability, we can express odds based on subjective things, experimental things, or theoretical things. We're going to concentrate on theoretical, but you could use other ones. Like, for instance, what are the odds you're going to pass this class? Now, where do the odds come from? You might say to yourself, oh, it's 50%. Well, percents are actually probabilities. Odds are ratios. Okay? And the way the ratio works is you have to take the probability of that event compared to the probability it will not occur. So we say the odds in favor, the odds that this happens, are the probability of it compared to the probability against it. But we usually turn that into a ratio. Okay, so something with a colon between it. When you look at odds, if the first number is small, that thing is not likely to occur. If the second number is bigger, it is likely to occur. So for instance, in 1 to 4, the chances of passing are actually 1. The chances of not passing are actually 4. Okay, so there's 1 chance you will, 4 chances you won't. Not very likely then, it seems. As opposed to something like 6 to 5, you're slightly more likely to pass it than you are to fail it. So one of the big ideas here is we need to have probability before we can do odds, because they're connected together. So let's try one. What are the odds of rolling a 6 with a regular dice? Well, I need the probability of rolling a 6 first. That's 1 out of 6. So I need the probability not rolling it. That's 5 out of 6. So what we usually do is we take our probability of it compared to probability against it. And you notice that the numbers on the bottom are both the same. They're both 6s. What we usually do is we ignore those. We cut them off. And then say for odds, the odds of rolling a 6 are 1 to 5. These two things together, the 1 and the 5, makes your universal set. They tell you how many things there are altogether. 1 plus 5 makes 6. So really, I know the probability if I know the odds. Okay, let's try something. Using 3 coins, we're going to flip them. We want to figure out the odds that they're all heads. So I have to think about what can I do with 3 coins. Well, it could be a head, and a head. That's one possibility. Or heads, heads, tail. Or heads, tail, head. Or heads, tail, tail. Or what else we could do? We could do tail, heads, tail. Or tail, heads, heads. Or tail, tail, heads. Or tail, tail, tail. There's really 1, 2, 3, 4, 5, 6, 7, 8 different possibilities. So what are the odds that they're all heads? Well, the probability of all heads is 1 of the 8. So the probability that they're not all heads, the opposite, the complement, 7 out of 8. So my odds are 1 to 7. The probability of it versus the probability against it. And notice I ignored the 8. I just canceled them out. Okay, how about at least 2 heads? So that means it could be 2 heads or more. Well, let's figure out the cases of 2 heads or more. This one, this one, this one, this one. 4 of them. 4 have 2 heads or more. So how many don't have that? What's the opposite? Well, turns out that's also 4 out of 8. So my odds are 4 to 4, or in other words, 1 to 1. There's an equal chance, a 50-50 chance, that I get more heads than tails. And now these are things that we call odds in favor, the odds that it occurs. We can also have odds against. And all that happens with odds against is we flip the ratio. So we do the not first, or the not first, followed by the probably it does happen or that it does happen. The math doesn't change, just the order. So you have to be careful when you're reading words, and that's going to be a constant theme in this course. You got to read carefully. Does it want the odds in favor or the odds against? So we got Dan here. The probability that Dan passes the next test is 40%. What are the odds that Dan passes? Okay, well, it didn't say odds against, it just said odds. So we assume that means odds in favor. So odds in favor are the probability of it compared to against it. So what's the probability of him passing? 40%. Failing? 60%. We have to add to 1, right? So we can say this is 4 to 6 or 2 to 3. Part B, however, says what are the odds against him? All we want to do is flip that around. Okay, so this is the not compared to the is. That's all that happens. Flip them around the other way. Read carefully. The odds against the golfer scoring a hole-in-one on a particular hole are 2,000 to 1. What is the probability they do score the hole-in-one? So we have to interpret this. They're telling us that it's the odds against. Well, if I know the odds against, I know this is A naught, and this is A4. I want to know the probability. I know that my universal set comes when I add these things together. So if I add 2,000 plus 1, I have all the possibilities. So my probability is going to be out of 2001. How many ways did he get the hole in one? The right way? One of them. So the probability that he actually gets a hole in one are 1 out of 2001. Okay, so there's theoretical probability. Our homework today is going to come from the book. And there is a book on the website. If you have, you can download it, or hopefully you have one. Try some of the questions. They take practice. This is going to take practice. A lot of the stuff in this course, every question is different from each other. You don't practice it, it gets really confusing really quickly, because a lot of them sound the same, but they are actually done in slightly different ways. So try the homework. If you're stuck, come see me and we'll figure some things out.